Okay, so as you guys just saw, Lewis was in charge of designing the tread linkages, and I'm in charge of figuring out how we're going to manage or manufacture them. So we had a few initial options for molding these because we decided we didn't want to buy them off the store shelves because the ones we bought last year were super, super heavy, and we couldn't really find ones that were a good weight requirement. So first we thought of 3D printing each link, which actually a lot of teams have done, but the cycle time is about 6 to 8 hours for each link, which I think is too long. Next we thought of resin casting, which is 24 hours for each link. Again, way too long, so not doing that. And then we found injection molding, which has a cycle time of about 30 seconds. And I've, for small parts, it's like 30 seconds. And I've co-opted with Little Tykes making the toys for about a year and a half, so I've had extensive experience with injection molding, so yeah. So for those of you who don't know what injection molding is, it is a process where molten plastic is forcefully injected into a mold. It cools pretty quickly, and then it's pushed out of the mold. And there's a little J. So this is a picture of an industrial machine. It's pulling out a giant barrel. But in the recent years, tabletop and DIY machines have become a lot more common. So it may seem like a daunting task to make an injection molding machine, but it actually is something that I think is pretty attainable for us. So this man recycles plastic in his little machine. Okay, so this is my current design. First I did just a sketch right there. So it's 3 main parts: a piston lever, a melting chamber, and then the mold at the bottom. And here is a more detailed version of my melting chamber. This is some parts I got off of MasterCar, so this is kind of what I'm thinking to use. It's like a 1/4-inch nozzle. It's pretty big plastic output. This is a picture of the resin you use. For anyone who didn't know, it just comes in little pellets, and it melts up pretty quickly. Okay, so the biggest roadblock for me is how to keep the melting chamber heated. So I'm a mechanical engineer, so my electrical engineering is not my forte. So we're thinking about using, but we have to keep the plastic around 130 degrees Celsius because that's the melting point of one of the ones we were looking at. And we have to keep it consistently at that. And in this injection machine that someone made themselves, they have like little, you see brackets around the melting chamber. So it looks like they have some kind of warm sleeve for the melting chamber. So yeah, so that's something everyone should definitely keep in mind if you're in electrical at the end of this presentation. I would definitely like to hear your thoughts on that. Okay, so really quickly, for the actual molds, we're thinking 3D print the molds or CNC them. So 3D printing injection molds is actually something that's come into industry recently. So companies do it like all the time, and it's actually more durable than you would think. So pros, fast creation, we can change the mold within a day, and it's easy to make changes. Cons, sensitive melting point, depending on what we choose, because we don't want to melt the mold when we put molten plastic in it. And then questionable durability. We don't know how many days, weeks, months that mold will last us if it's just plastic. A CNC mold, or CNC printed, that's a typo. So it has a high melting point. We won't have to worry about the mold melting. And it's durable, but we couldn't make changes easily, and I don't know anyone who has a CNC machine, so we would probably have to go through the university. It would be a bit more of a gauntlet where we have a 3D printer in our office at the moment. So it's just a question of accessibility. And that's all I have. So let's open, okay.